Okay. So now we will do some of the problems of chapter number 16. Let's do problem number 3 first. It's a very easy problem. Um, so in this problem, a wave is given with an angular frequency of 110 radian per second and a wavelength of 1.8 meter. So the angular frequency is 110 radian per second and wavelength is 1.8 meter. So we have to calculate angular wave number and the speed of the wave. So k and v. Now we just have to write the formulas and insert these numbers. So k equals 2 pi by lambda, 2 pi over 1.80. So this number turns out to be 3.49 per meter. And v can be figured out using the formula v equals f lambda, and f is equal to omega over 2 pi, and this is lambda. So omega is 110 multiplied by 1.80 over 2 pi, where pi is 3.14. So we will become 31.5 meter per second. So these two are the required answers. So next we have problem number 4. Okay, so in this problem you are given that there is a sand scorpion who can detect the motion of a nearby beetle. So let me draw the respective diagram. So this is scorpion, and it can detect the motion of this beetle. So beetle is the prey of scorpion. So you can say the scorpion wanna eat this beetle. Um, and so how he can detect this beetle? By the waves which are producing on the surface of the sand with the motion of the beetle. So these waves are of two types. So for example, by the motion of this beetle, the waves are producing, and the waves are of two types. So say these are the waves, and the distance between beetle and the scorpion is d. Let me write this here. So the two types of waves that are producing here, longitudinal waves and transverse waves. So this way represents the velocity and direction of the waves. So similarly, over here too. So now the data is given in a way that the speed of transverse waves is, so T is for transverse, 50 meter per second, and the speed of longitudinal waves is 150 meter per second. So if we assume that delta t, the time difference between two snapshots of the waves is for 4 millisecond. So 4 multiplied by 10 is to power minus 3 second. We have to tell what is this distance d. Since both of the waves, whether transverse or longitudinal, are emitting from the same source, so they will both have the same equation of motion, s is equal to vt. It means I can write d is equal to, for transverse wave, v sub t multiplied by t sub t. Similarly, I can also write d is equal to v sub l t sub l, because both equations follow the same equation of motion and the system is non-accelerating. So by comparing these two equations, I can write Vt t sub t equals V sub L multiplied by T sub L. By rearranging, I will get T sub T by T sub L, V sub L divided by V sub T. So this is 150, this is 50, this is 3. So T sub T is 3TL. So this is the relation between times of longitudinal and transverse wave. Now, if I'm assuming this definition this way, so there is no hard and fast rule to define the time difference in this way, that transverse wave is with positive t while longitudinal wave is with negative t. So in the other way around, you will get an extra negative sign, which you will have to by remove by hand because the distance can't be negative. So since this number equals 4 multiplied by 10 is to power minus 3, and t sub t is 3 t sub l minus t sub l, so this will be 2 t sub l. So simplification will yield t sub l equals 2 multiplied by 10 is to power minus 3 second, or 2 millisecond. Now, by putting this, so if from either from this you can calculate uh, t sub t. So once you have calculated t sub t, you can find the distance using both of these equations, either from equation number one or from equation number two. But I think there is no need to calculate t sub t, so I can simply put t sub l into the equation number two. So equation number two becomes d is equal to v sub l multiplied by t sub l, and v sub l is 150 multiplied by 2 multiplied by 10 is to power minus 3. So this distance will come out to be 0.3 meters. So this is how we can find this distance between beetle and the scorpion. So in this way, scorpion will know how far away the beetle is. Okay, this is problem number 4. Let's do problem number 5 now. In problem number 5, it is given that a sinusoidal wave is traveling along a string. So a sinusoidal wave is traveling along this string. This is the direction of the wave. And definitely here is t and here is x. The time for a particular point to move from maximum displacement to zero. Okay, so the time which is taken by a particular point from moving from this point to this, so from A to B. So this time is given, which is t is equal to 0.0 seconds. So we can see that this t is the 1/4 of the total time period. Okay. So now we have to find the time period and we can calculate time period from this relation. T is equal to 4t. So 4 multiplied by 0.170. So t will come out to be 0.680 second. So this is the answer to part A of this question. And in part B, we have to find frequency. Frequency is just 1 over t. So this is 1 over 0.60680, and frequency will become 1.47 hertz. In the next section, it is given that the wavelength is 1.4 meter. What is the speed of the wave? So it's very easy to calculate since v is equal to f lambda. Now either you can use f or you can use this relation 2, lambda over t. So both of relation will yield 2.06 meter per second. So the wave is traveling with this speed. Okay. So these are relatively easy problems. Now I'll do a complicated problem, and this will be our last problem of the session. However, if you have any more problems that you want me to do, you can let me know anytime, and I'll try to do as soon as possible. So let's do problem number 7. This is a very interesting problem, and which can also help us to understand many different concepts. So it is given that a transverse sinusoidal wave is moving along the string in the positive direction of an x-axis with a speed of 80 meter per second. So this is a sinusoidal wave which is traveling in the positive x direction with velocity v. So the speed of the wave is, let me choose some other color. So v is 80 meter per second. At t is equal to 0, the the string particle at x is equal to 0. So it is given that at t is equal to 0 and x is equal to 0, string particle is at a transverse displacement of 4 centimeter from its equilibrium position. It means that I should redraw this wave in this form. Um, so now and this axis shows. So when you are going to start this oscillation, t will be 0, and at this point x is also equal to 0, because this point this point is lies on y-axis. X will definitely be 0 at this point, and the time at which we are starting this oscillation will be t is equal to 0. So x is equal to 0 and t is equal to 0. But this distance from the mean position to equilibrium position is 4 centimeter. So we can see that this is just simply the amplitude of the wave. So I can write ym to be 4 centimeter, or 4 multiplied by 10 is to power minus 2 meters. Then it is given that the maximum transverse speed of a spring particle at x is equal to 0 is 16 meter per second. And transverse speed at x is equal to 0 is 16 meter per second. Now I can also write this thing as v of t evaluated at x is equal to 0. Both are these equivalent notations. Now we have to find the frequency of the wave. So there are a couple of things that we have to calculate in this question. So first of all, we have to find the frequency of the wave. In part A, what is the frequency of the wave? So we know that frequency. The relation that we have for frequency Rf is equal to omega over 2 pi. But we have no idea what omega is. So first we have to calculate omega. So this is my equation number 1. Now the thing is, how can I calculate omega? So to calculate omega, I will have to use one of the first relations of simple harmonic motion, that is the transverse wave. The speed of the transverse wave is equals some constant, which is the amplitude of the wave multiplied by frequency. And we have calculated this relation in one of our previous classes. From this, I can write omega equals v sub t over y sub m, and v sub t is 16 divided by y sub m, it is 0.04. So omega will turn out to be 400 radian per second. Now I can easily calculate frequency. So frequency will be 400 divided by 2 pi. Again, pi is 3.14. So frequency will be 64 hertz. So this is part A. Now in the next uh, part of the question, we have to find the wavelength of the wave. So we have to calculate lambda. V is equal to f lambda. Again, I can write this V sub t. Or I think so. Just keep it V is equal to f lambda. So lambda equals V over f. And now we have both of these values given in the question, and one of the values we calculated. So this will be 80 divided by 64. So lambda will be 1.26 meters. This is the answer to part B. Before proceeding to part C, I think we have to keep in mind some extra information. Now, just let put me a box here. The wave equation is if wave equation is y x t y sub m sine kx plus minus omega t plus phi. So then we have to calculate y sub m, wave number, angular frequency, value of this constant phi, and sine of phi. So let's calculate. I'll just put my question marks here. So part C. Amplitude is already given in the question. So since in the question it is given that y is equal to 4 centimeter. So this will just be our amplitude. So y equals 0.040 meter. Already given in the question. This is just the transverse displacement. Part D. K, you have to calculate D, and this can be calculated using the formula K equals 2 pi by lambda. So 2 pi divided by lambda, which is 1.26. So this will give K to be 5 radian per meter. Part E. We have to find angular frequency, but we have already calculated omega in part A to find linear frequency F. So omega was 400 radian per second from part A. Omega equals 400 radian per second. Okay, so to find out phi, uh, um, let me call this equation number 1. Or if I chose equation number 1 earlier, no, I did. So there is an equation number 1. Let me call this equation number 2. Equation number 2 becomes by putting all the calculated values. So y, x, t, ym is 0.04 sine 5x minus 400t 400t and plus 5. So since the wave is traveling towards right as given in the question, so I just put negative sign here. I didn't introduce the positive sign. And at x is equal to 0, y is equal to 0, it is given that wave was initially at this position. So it means y of x is equal to 0 and t is equal to 0 is just b equals to y of m. So this is the initial value of the wave. It means that this is y of m and this is also y sub m sine. So this term will be 0 because x is 0. This term will be 0 because t is 0. So this will just be sine of phi. So this will be cancelled out with this. 1 is equal to sine phi. So phi is equal to sine inverse 1, which is phi is equal to pi by 2. So this is how you can calculate phi. Since phi is positive, so if I have to find the sine of phi, then it will be positive. But I have just seen that we have to calculate the correct choice of sine in front of omega, not in front of phi. So there will be an omega. So let me write the answer here. Since wave is traveling towards right or towards positive axis, positive x-axis, so negative sign. So this is what we have to calculate in this question. So all of the stuff from this second portion of the lecture. Thank you.